Let us see about impulse response. After completion of this topic, the students can able to analyze the spectral characteristics of continuous time periodic and aperiodic signal using Fourier analysis, and also they can classify the system based on their properties and determine the response of LSI systems using convolution. Now we can see what is meant by impulse response. When the input to a discrete time system is a unit impulse del of n, then the output is called an unit impulse response of the system and is denoted by h of n. And the impulse response h of n equal to h of h of del of n. That is del of n. If it is given to a system function, we are getting the output as h of n. And next we can see about impulse response of interconnected system. The interconnected system can also be divided into, that is parallel. First one is parallel connections of discrete time system. That is by using the distributive property we are applying the parallel connections. In this, let us consider two LTI system with impulse response h1 of n and h2 of n connected in parallel. It is shown in figure. Here let us see, here we are connecting two systems, that is x of n, it is given to two, that is we are connecting two systems h1 of n and h2 of n. These two systems are given to a same input h of n, and again it is given to the same output y of n. Finally we can write this as h of n equal to, we are adding the system, since two systems are available in parallel, we can write this as h of n equal to h1 of n plus h2 of n, and finally we get that the discrete Fourier transform of y of n is x y of e power j omega. Similarly, y of n minus 1 is j omega into e power minus e power j omega. Therefore, by using the same concept, we are just finding the dTFT for this equation. Here, from the LHS side, we are taking this y of e power j omega outside, and this is common, and x of e power j omega outside, and finally we are finding the value of h of e power j omega equal to y of e power j omega divided by x of e power j omega. Finally, we are getting this equation, and here this is the frequency response, that is h of e power j omega, that is the frequency response. H of e power j omega equal to y of e power j omega divided by x of e power j omega. And here there are also asked to find the impulse response. Therefore, for finding the impulse response, by applying the partial fraction expansion, we are dividing the system function into 2 and we are factorizing the denominator term. Similarly, we are finding the value of a and b by substituting the similar values for e power j omega. Finally, we are finding the value of a and b. After finding the value of this constant, we are substituting in that particular in the above equation. Therefore, we are getting the value of h of e power j omega as it is shown in this equation. Here, if you want to find the impulse response, we want to apply the inverse discrete time Fourier transform. Therefore, we are just applying the inverse discrete Fourier transform. The inverse discrete Fourier transform h of e power j omega is h of n, and here the inverse discrete Fourier for this term is 1/3/5 into 1/2 the whole power n into u of n, plus here 2/3 into minus 1/3 the whole power n into u of n. Therefore, by thus we are finding the impulse response and also the frequency response for the given system function. This is the possible quiz question in the case of impulse response. Thank you.